Tonight we're going to talk about scatter plots. First thing I'm going to have you do is go ahead and set up your notebook in your Cornell style. So go ahead and draw your line down the center of the paper here. We're going to go ahead and start with line graphs, which is a topic that you covered for several years now. And from that, we're going to kind of tie it into scatter plots. So your line graphs are useful for displaying information that changes over time. Here's kind of a little mini example for you here. This is nothing new for you. This is something you've been doing for quite a while now. Time, one of the things that I think people struggle with a little bit is your time frame will always go along the x-axis, okay? So your seconds, minutes, hours, days, weeks, whatever your time frame is, it is going to go along your x-axis. Let me go ahead and show you a quick example of a line graph. Here's an example of a line graph that's going to show distance over time. And so you can put this kind of graph into any kind of a real life situation, but here what it is saying is that as time goes on your x-axis, so as you go along the x-axis, the time is continuing. As the time continues, the line also continues along that horizontal line. So as you continue, as time goes on, you can see that the distance away from home is getting longer and longer and longer. So to me, this looks like the car is traveling at a constant rate of speed. And then here, time is continuing. So as you move along this x-axis, this line is continuing to move in a direction to the right. However, you can see at this point, the distance stops getting higher. So at this point, you can see that the car is no longer moving. So maybe this family is going on a picnic. So they're driving, reach their destination. Now they have stopped the car and they are sitting at their picnic. At this point, they're going to continue with time, and that return trip home is going to be happening here. So the distance, again, your y-axis here is distance. The distance is now decreasing, which tells me they are going backwards, or they're returning home. So as you go along the x-axis, you need to see what is happening to this vertical movement. Is it going up? Is it staying straight? Or is it going down? Okay, so from that idea of a line graph, we can now take that into a scatter plot. A scatter plot is a graph that shows a relationship between two sets of data. It does not have to involve time. So on this type of a graph, on a scatter plot, we have those dots that represent pieces of data, the relationship between the x-axis and the y-axis, or the x-coordinate and the y-coordinate. But you're not going to connect those dots because they don't have that continuous relationship over time. So again, a scatter plot is a graph that shows a relationship between two sets of data. There are dots, but those dots are not connected. There are three different types of scatter plots. There are three different relationships, or three different types of scatter plots. The first type is a positive relationship. Anytime you have a scatter plot where the dots are kind of random, but they're kind of going into a pattern where they're going upward and to the right, you are looking at a scatter plot that is showing a positive relationship. So from that, you can probably guess what the second type is. The second type is a scatter plot where you have a negative relationship. And again, you can see from my little mini example here that this one is going to have an x and y relationship where the graph is showing dots that are kind of randomly going in a pattern that are going downward and to the right. So they start high and come down low. On this one, you notice they started low and went up high. This is increasing, this is starting high and decreasing. The third type, you don't necessarily have to have a relationship when you have a scatter plot. So the third type is when you have no relationship. The dots are kind of randomly spaced anywhere along your x and y axis. Okay? Another part of a scatter plot that is extremely important to predicting what may happen is something called a trend line. A trend line is an implied line that goes through the middle of most points. So if your points are in any kind of a positive or negative relationship, you can start at your origin and draw a line, an imaginary line, that will go through about half of the points. So about half the points will be above the line, half the points will be below the line. That is called your trend line. A trend line is very important to predicting what may happen in the future. So as I go along my x-axis, I can see that I'm having, in general, a positive relationship. And so I should be able to look anywhere in the future here, follow it up to that y-coordinate, and wherever it would hit that line is where I can predict that it is possible for that y-coordinate to occur. Okay, so this is the general idea of a scatter plot. Let me go ahead and go to the left side of my spiral, and let's go through some examples. Okay, so I'm going to go ahead and give you two relationships here, because remember, a scatter plot is a relationship between two sets of data. So let's say that my x data is playing time. Maybe it's basketball, maybe soccer, whatever that may be that involves points. And my y coordinate is going to be the points that are scored in that game. Do you think that would be a positive or a negative relationship? Playing time versus points scored. Well, one of the things that you can do if you're stuck here is you can make yourself a little mini graph. Think about your x-axis. Down here would be playing time. As time goes on, what is going to happen to the points scored? Well, if I'm not playing at all, I'm not going to score any points. If I play for 1 minute, I might be lucky to score 1 point. But if I play for 30 minutes, my chance of making some points is pretty good. So you can see that it's starting low and it's going to continue high. Now again, these points might be kind of random depending on what kind of a player you are. But in general, if you start not playing at all, you're not going to make any points. But as time goes on, you're more likely to make more points. So this, ladies and gentlemen, is a positive relationship. Okay? Here's another example. Your weight and your month of birth. Is there a positive, negative, or no relationship when you are comparing your weight to your month of birth? Remember, the first one listed is your x-axis. The second one listed is your y-axis. This has no relationship, okay? Your weight has nothing to do with the month that you were born in. People who were born in September are not any heavier or lighter than anyone born in December. It doesn't say anything about the year you were born, only the month of birth. So these will be kind of random. Age and physical activity. So how old you are versus your amount of physical activity. Do you think this would have a positive, negative, or no relationship? If you're having a hard time visualizing it, by all means, please make yourself a little example, a little graph. And so that was something that I did here. Again, I just did a really quick one. So I did my x-axis is the age, y-axis is physical activity. When you're born, you actually kind of nap a lot. So there's not a whole lot of activity when you're born. I can tell you that my 4-year-old, my 5-year-old has a lot more activity than I do some days. And so she's pretty active. That can tend to stay the same, go down a little bit, kind of move around. But as you get older, as you hit your 40s probably, your activity level is really going to start dropping. 80s, 90s, 100 is going to have very little activity. So in general, this is going to start fairly high. Again, we have an outlier here. But in general, it is going to start fairly high and then kind of randomly go down. Now, are there going to be more points than this? Absolutely. Every person is different. So we're going to have all kinds of random points in here. But in general, it's probably going to come down. Because it comes down, this one would have a negative relationship. Okay. What I'd like to do now is give you some multiple choice questions for you to kind of try on your own. Here is question number 1. What is implied when it is said that x and y have a negative correlation? I would like you to stop the video at this point, read your choices, and give me an answer, please. Okay, for question number 1, what is implied when it is said that x and y have a negative correlation? You should have had answer choice D for this one. says when the value of x increases, the value of y decreases. So as you go along that x-axis, the y is decreasing. That line is coming down. So that's going to give you that negative correlation. Question number 2. Which relationship would most likely have a positive correlation? Please stop the video at this time, read your choices, and answer it. Turn the video back on when you are ready. For question number 2, you should have had choice B. Which relationship would most likely have a positive correlation? The number of tickets sold for a baseball game and the number of hot dogs sold at the game. The more tickets you sell, the more hot dogs you're going to sell. So as you go along that x-axis, as you increase your number of tickets, you should increase the number of hot dogs. The more people there are, the more the hot dogs are going to sell. Question number 3. Which scatter plot would most likely represent the relationship between D, the distance that a person throwing darts stands from a target, and C, the number of times he or she hits the center? Turn the video off, please. Answer this question. Turn it back on when you're ready. Question number 3 should be C. Distance that a person throwing a dart stands from a target. If I'm standing very close to the target, hopefully I can hit that target quite often. The farther I move away from the target, the less likely I am to hit that bullseye. This is a negative correlation. Okay, 2 more questions to go. Question number 4. The scatter plot below compares the horsepower of various engines to the average mileage of a car with a particular engine. What does the point with the box around it represent? Turn the video off and come on back when you're ready. Okay, for question number 4, you should have had answer C. You can see for this one that if you go along the x-axis, this point with the box around it is at my x-coordinate of 200, and it hits the y-coordinate at 25. So that tells me my engine power, my horsepower is at 200, my miles per gallon is at 25. So 200 horsepower to 25 miles per gallon. And your last question for tonight. Which scatter plot shows that x and y have no correlation? I'll give you a minute. I will pause here. No correlation is going to mean that your dots are randomly scattered. This one to me is a negative correlation. This is a positive. This is also a positive. This is your random one. Because the dots are randomly spaced, I do not see any trends of positive or negative. This one is A. Thank you. I'll see you tomorrow.